Hello, hi again. Today we are going to cover factoring, a difference of squares. That's another type of factoring for this section. It's quite straightforward, just a couple of things to deal with, and that's it. All right, first, what is difference of squares? Well, I just put down x squared minus y squared to kind of explain to you what the difference of the squares mean. Well, each of these guys are perfect squares, right? X squared is a perfect square, so that's the perfect square. And y squared is a perfect square. And this minus sign in between, that's the difference. That's why we call it difference of the two squares. All right, we need to be able to, at one point, to put it into a factor form. And remember, factor form, writing the polynomial as a product, as an expression of a product, okay? And that's what we're going to be doing, that each of these brackets will have two terms in them, and x and y, and we want to see what's happening with that. So let's go through a kind of a review first. All right, I need you guys to do this multiplication. Okay, just do that right now, and let's see what happens, and then we'll continue shortly. Okay, once you've done the multiplication, you should get something like this. All right, and I did the rainbow for you as well, the red path and the blue path to show you what's happening. So that's what you will get. Let's simplify that, and if you simplify that, we notice that xy and xy, these are like terms. That xy and minus xy, that actually becomes 0, because one xy minus another xy, that's 0. The only thing that's left now is x squared minus y squared. Now I'm going to just write it in one color, so that's x squared minus y squared, and that is basically same as that. Okay, so this is a factor form of the x squared minus y squared, and it turns out that that's exactly what that is. So difference of squares, as long as they're perfect squares, the factor form is x minus y, x plus y, and notice the pattern. Each of the bracket will have x and y in them. Well, first bracket will have a negative sign, the second bracket will have a positive sign. Okay, let's go through a couple examples. First one, x squared minus 49. We want to factor that. Let's see what happens. So first we have to make sure that both of them are perfect squares. X squared is a perfect square and 49 is a perfect square, and there is a negative in the middle, so that's a difference of squares, and then we can use this factoring pattern. So here it is. We say this is, so both brackets, you open up two brackets, both of them will have an x and x in there, will have a 7 and 7, because the square root of 49 is 7, or 7 times 7 is 49, and then the first one is negative, the second one is positive, or vice versa, by the way. It doesn't matter. You can start with the positive and then put the negative in the second bracket. But that is it. That is the factor form of x squared minus 49. Let's look at example B. Same idea again. Let's first check perfect square, numbers, and the variables. 81 is a perfect square number. Y squared is a perfect square variable. X squared expression. X squared as well is perfect square expression, and 16. So let's go through that again. So that is two brackets opened up. First one will have a 9y in there, and so as the next one. And the second part of each of the brackets will have a 4x and 4x, because 4x times 4x is 16x squared. And then next, the first one I'll put minus, the second one plus. I got used to doing that, but you can start with the positive first and the negative second. All right. Okay, so let's look at this question, example C. same idea again, but this time, yeah, when we check for the perfect square, you notice that 8m squared and 72, they are not perfect squares. All right, so the first thing we have to do always when you're dealing with factoring is that you check for GCF. If there is a GCF, doesn't matter what kind of a factoring question you have, you always check for greatest common factors of all terms. So we take that out first, and once you do that, then whatever you are left with, then you can look at it and say, okay, what type of a trinomial it is or binomial it is, and then you go ahead and you factor that inside the bracket. So in this case, we know that factor 8 is a common factor for both, greatest common factor. Take that out. So taking 8 out of the 8m squared will give you m squared, and then 8 out of 72 is going to be 9. Look what's happening here. M squared minus 9, that's a perfect square now. Okay, so that's a difference of a squares. We can factor that, and that's what you will get. Okay, example D, this should say 28b. Just to make sure that is correct. All right, so same idea again. We check for GCF first, because neither one of these guys, they are perfect squares. So the GCF of both of them, 7b, that goes, that's the GCF, and take that out, and you will end up getting 9a squared minus 4. Close the bracket. Okay, and for the purpose of this, so 7b, you leave the 7b alone. Inside 9 squared minus 4, that's a difference of a square. So now you can just go right ahead and factor using a difference of a squares. And so 9 squared becomes a 3a, and 3a for each of the brackets, and 4 is a perfect square as well. 2 and 2 for each of the bracket. Make sure the signs are changing. All right, okay.